Hello, good morning. My name is Matilda Sepúlveda and I am from Claudio Urrutia High School in the city of Cauquenes, Chile. Today I will present my research project titled Potentiation of the antibacterial effect of Masaela laminarioids with copper nanocubes in vitro against Escherichia coli and Staphylococcus aureus. You might be wondering what Masaela is. It's a non-endemic red algae with ecological and economic significance, often used for carrageenan extraction. It is valuable in food and scientific research. Masaela grows in the central southern and southern regions of Chile, specifically in the mid to low intertidal zones, clinging to rocks. Its color ranges from brown to yellowish, typical of Rhodophyta. This algae is also found in the coastal areas of Chile, mainly native to southern Argentina and the Falkland Islands, providing habitat for herbivores and contributing to the marine ecosystem. Why algae? Because my project stems from a research workshop in our science academy that focuses on microbiology. With my collaborative teacher, we have been exploring innovative alternatives to find naturally sourced antibiotics for a long time. That's why we chose this algae. It's easily accessible and non-protective. Actually, as you can see the sampling area, we had to travel many kilometers through the areas of Loanco, Chanco, Peyúgue and Curanipe, approximately 40 kilometers. Where we collected various samples of this algae, we were intrigued by the fact that it is something from our region and we believe we could add value to it. Here you can see the morphology of Masaela, displaying its thallus and adhesion discs. It's worth noting that there are various types of algae, including laminars and foliaceous varieties like Cochayuyo or Güero, which are also found in our region. However, Masaela is a laminar algae and we decided to work with it. We had previously conducted a research project with Cochayuyo, but unfortunately it is of a mixed nature. In this case, the laminar nature of the algae makes it easy to handle because it is homogeneous, making it more accessible for our laboratory work. But why nanoparticles? These are very small compounds measured in nanometers. However, in our research, we wanted to work with nanoparticles because they represent the future of pharmaceuticals. I realized that silver and lithium nanoparticles are highly toxic. Additionally, during my investigation, is that modern medicine is increasingly working with the microscopic world, utilizing various types of nanoparticles. In the end, I decided to work with copper nanoparticles because they are less toxic to the body and they are also easier. We had to conduct research and seek advice from the university to find the most accessible protocols and replicate them in our high school laboratory. This leads us to the following research problem. Does the antibacterial effect of the extract from the blades of Masaela laminarioids with copper nanoparticles get enhanced against strains of Escherichia coli and Staphylococcus aureus? The general objective of the research is to evaluate whether the administration of Masaela laminarioids with copper nanoparticles enhances its antibacterial properties against Escherichia coli and Staphylococcus aureus strains. And why these two bacteria? Because both are of clinical interest and have become highly resistant to traditional antibiotics. The specific objectives are to elaborate on an extract from the algae blades, then synthesize copper nanoparticles in vitro with a well-established and non-toxic protocol, to mix them with Masaela extract to perform the antibiogram technique, testing the mixture against bacteria, and finally to compare the inhibition of bacterial growth with the combination of nanoparticles plus Masaela to see if it is efficient or enhanced against the mentioned bacteria. In this way, the research hypothesis is the antibacterial inhibition of copper nanoparticles with extracts of Masaela laminarioids blades, in this case established experimentally by the simple diffusion technique of antibiogram, Kirby-Bauer at 0.5 McFarland, and halos of inhibition, enhances its antibacterial effect against strains of Escherichia coli and Staphylococcus aureus. With this mention, I move on to my methodology, which was divided into two main parts. First, field work, and second, laboratory work. The first step involves collecting this algae in the intertidal coastal zone of the Cauquenes province on the rocks where they are attached. We had to go approximately from May to June before the cave became too strong, making it difficult to collect appropriate samples. We used the quadrant technique as shown in this image, where we randomly took samples with tweezers and gloves. To process them more effectively, we stored them in sterile Ziploc bags and transported them in our high school laboratory. This was crucial because the salinity from the marine environment exposes them to a process of putrefaction or disintegration if not processed promptly. In the laboratory, I cleaned the algae with distilled water, removing calcareous sediments from some invertebrates that also inhabit the algae. I eliminated seawater residues and proceeded to prepare the extract. Here, I had to explore some techniques because initially I started experimenting with wet extract. I realized that I could also work with dry weight, and dry weight yielded better results. To achieve this, I took pieces of the algae, macerated them, and mixed them with various solvents. I began with distilled water, but the algae did not dissolve well. I then dried isopropyl alcohol and ethyl alcohol, but these solvents also did not mix well. With the guidance of my teacher, we had to use another type of organic solvent to achieve a proper mixture. We decided to use 99% propanol, also known as acetone. The mixture was subjected to a rotary evaporator, essentially a simple distillation system controlled for temperature. To avoid accidents due to the low boiling point of propanol, 56 Celsius, we chose to work in a university setting with more controlled conditions. We worked with dry weight, and dry weight yielded better, subjecting the algae to drying in a culture oven for 24 hours. Once we obtained the separation of our pure extract, we worked in the school laboratory using a microbiological technique called the antibiogram or Kirby Bauer. We tested with sensitivity disc, but realizing the need to mix it with the nanoparticles, as I will explain shortly, we had to create well-supplied pure extract hydrated with physiological saline. This technique is known as well-played methodology. After obtaining the extract, we tested it, and the extract alone showed antibacterial results. However, in our research, we wanted to enhance it further, leading to the second part of the laboratory work with assistance of the Nanomedicine Center at the University of Talca to synthesize nanoparticles. We also work with bacterial strains from the ATCC, an acronym in English for an American repository called the American Type Culture Collection. These are laboratory bacteria, not patient samples, as using patient samples could pose problems for us and go against the school regulations. Therefore, we chose to work with bacterial strains that can be attenuated in collaboration with my professor, where Escherichia coli ATCC 25955 and Staphylococcus aureus ATCC 25923. We selected this as control because there are many types of bacteria classified based on their bacterial wall into gram-negative and gram-positive. Escherichia coli has become highly resistant being gram-negative, and Staphylococcus aureus has also developed resistance as a gram-positive bacteria to commonly used antibiotics. These bacteria are known as multi-resistant bacteria. The regional hospital in Talca provided us with these bacteria, which were frozen at -20 to -25. They saw them and transferred them in a medium called BBL. This allowed us to receive them 2 to 3 times per week in the high school laboratory. As we have the necessary equipment to work with them, having an incubator, a refrigerator, and the required culture media. Escherichia coli grows on McConkey agar, which inhibits the growth of gram-positive bacteria. Only gram-negative bacteria grow. Escherichia coli is indicated by a fuchsia color as shown in this image. In the case of Staphylococcus aureus, we use the saline mannitol culture medium, which inhibits the growth of gram-negative bacteria, allowing only gram-positive bacteria to grow. Additionally, Staphylococcus aureus is characteristic of catalyzing changing mannitol, as shown in this image. To synthesize the nanoparticles, I use copper chloride with a concentration of polyethylene glycol. As shown in this image, I employed only mixing techniques. I prepared a solution of copper that was evaluated with Seisencore software. The images displayed show an average of 440.3 nanometers and 544.7 nanometers, demonstrating an increased resolution. As you can see, the nanoparticles are nanocubes, which is what successfully synthesizes in my project. Additionally, here are the graphs from another device called the synthesizer with CS Explorer software. which allows for quantifying the existence of the nanoparticles. This is crucial as this equipment has the capability to highlight them. Also, it generates a graph showing the average that 98.7% of the nanoparticles have an average of 168.9 nanometers. This sample was placed in a 10 mm coarse cuvette and all measurements were calibrated. Another crucial aspect is the determination of other characteristics such as the Z potential, which is a measure of the electric charge that nanoparticles can have. Using this program, if you look at this graph, you can observe these curves. For this purpose, a dynamic light scattering technique was used, relating to analysis of light or another type of spectrum. The graphs here show a result indicating a voltage of -60 mV. If the potential is greater than the range of -25 mV, it is said that they do not agglutinate, meaning they can disperse and are more stable. In the case of my nanoparticles, this graph here shows a value of -60 mV, which is greater than the range of -25 mV. I have presented the following statistical results with the help of my teacher. In the high school, using GraphPath 9.0 software, we created a table that includes Escherichia coli with a concentration of Masaela and the average standard deviation of copper nanoparticles, the control antibiotic, and the mixture of copper nanoparticles with Masaela. As you can see here, we use an alpha of 0.05 with a confidence level of 95%, which is statistical. To analyze and compare them, we perform a one-way ANOVA test. This step gives us a p-value for comparison, which has to be less than 0.0001 to be significant. It provides a p-value with 3 asterisks for Escherichia coli and for Staphylococcus aureus it's 4 asterisks. Additionally, we compared it with our antibiotic and all of this was done in triplicate. The graphs here display the following results. As you can see, the Masaela are depicted in green. For Escherichia coli, they achieve an inhibition of 11.17 mm and for Staphylococcus aureus, it is 18.65 mm. Below the copper nanoparticles I represent in red. For Escherichia coli, they achieve an inhibition of 16.40 mm and for Staphylococcus aureus, it is 16.75 mm. In blue, we have gentamicin with an inhibition of 14.59 mm for Escherichia coli, and for Staphylococcus aureus, we have tetracycline with an inhibition of 17.56 mm. The yellow bars represent the mixture of copper nanoparticles with Masaela. In the case of Escherichia coli, there is a much higher inhibition of copper nanoparticles with Masaela, achieving an average inhibition of 19.25 mm. For Staphylococcus aureus, the mixture of copper nanoparticles with Masaela, there is also higher inhibition with an average inhibition of 21.66 mm. Interestingly, Masaela alone also exhibits significant inhibition, surpassing both the copper nanoparticles, tetracycline, or coming very close. Therefore, as a conclusion, my main motivation is to open a new line of research in antibiotics, seeking to improve techniques. The bacteria I work with are multi-drug resistant in patients with clinical interest focusing on Staphylococcus aureus and Escherichia coli. I obviously work with ATCC bacteria, which are from a specific culture medium. I aim to enhance the field of nanomedicine, which holds great potential in microbiology, biotechnology, and pharmacology, particularly in synthesizing copper nanoparticles and combining them with a drug like Masaela. It is also possible to identify substances that might be present in the algal extract using techniques like HPLC or mass chromatography. From my research, it appears that a mixture of metabolites might be responsible for the inhibition, and I am unsure if it is bacteriostatic or bactericidal. Hence, I need to separately test which substances are present in the algae. I believe there might be some carrageenans or organic acid or oils, which I need to investigate. This will be the second part of my research. They provided us with this bibliography of my research. That concludes my presentation.